So we'll try to get through this stuff semi-quickly so you'll have time to work on it, so maybe you don't have to take it home. So these just say add or subtract as indicated, so most of them are going to have a common denominator, so you're going to have to find it. So 3 over z plus x over z squared. So I need to get a common denominator, so what do I need to do to get that?
Move z squared and then move z and then multiply by 2. Right?
You're making it a little more complicated than it needs to be.
That's me.
Just square the first one.
Yeah.
Oh,
I just need to multiply this one by z over z.
okay, that makes
You don't necessarily have to change both of them. Sometimes you do because there's no common thing, but in this case there is. So this ends up with 3z plus x over z squared. Um, 62. So this one is going to require us to do something to both. So m plus 1 over m minus 1 plus m minus 1 over m plus 1. So what do I need to do to these to get a common denominator? What you said last time would work for this one.
do that.
Okay, so this one's going to be multiplied by m plus 1 over m plus 1. And this one's getting multiplied by m minus 1 over m minus 1. So on the bottom, I have, I would probably initially leave it in like the factored form, and then if we need to, because sometimes things will end up canceling for us depending on what we end up with, so I like to leave it. On top, I would go ahead and I would multiply each thing. So these are two perfect square trinomials on top. So this first one is going to be m squared plus 2m plus 1. And then it's plus everything over here, m squared minus 2m plus 1. Okay, do we follow that? So then I can cancel some stuff. 2m's cancel. And then I'm left with m squared plus 2. 2m squared, sorry, plus 2 over, and if I wanted to, it doesn't look like anything's gonna cancel for me, so I can go ahead and do m squared minus 1 because that's going to be a difference of squares on the bottom. So you can leave it here, or the way the book might give you the answer, they may take out a 2 from the top and leave you with m squared plus 1 over m squared minus 1. So either of those would be sufficient answers for that one. In the actual section, there's 88. All right, so I'm going to look at 76 next. So these just say to simplify each complex fraction. So complex fractions are fractions in fractions. They tend to be a least favorite of a lot of people. So this is 2 plus 2 over 1 plus x all over 2 minus 2 over 1 minus x. So basically, what you have to do is you have to get a common denominator on the top so that you can combine those two things, and then you need one on the bottom so you can combine those two things. Okay? Once we do that, we can keep, change, flip, and all the fun stuff, and then things usually cancel pretty nicely for us. So, what would my common denominator on the top be? Or what should I get it to be? 1 plus x, so I'm going to be multiplying this by 1 plus x over 1 plus x. And what about the bottom?
1 minus x.
1 minus x. So, on top, we're going to have 1 plus x in the denominator, and then I need to multiply or like distribute this 2 through. So it's going to be 2x plus 2 because of this other 2 as well. All over. Do the same thing down here. It's all going to be over 1 minus x. So then the top is negative 2x plus 2, and then minus 2 from what was already there. So then this 2 plus 2 here is going to become a 4, and just to not have to rewrite the whole thing, I'm just going to draw a line through it and write that that's 4 now. Down here on the bottom, the plus 2 and the minus 2 cancel each other, so I'm just going to get rid of those. So now I can keep, change, flip. Okay, I have a fraction and a fraction, so that's the same as dividing. So I'm going to multiply by the reciprocal. So this is going to give me 2x over 1 plus x times, I'm flipping this one, 1 minus x over negative 2x. Are we following still? Tracking. So then 2x and 2x cancel. Now the negative sign is still here, so don't forget about it. There's nothing else that can cancel. Sometimes people start trying to cancel the ones, but because they're being added or subtracted with that x, they have to stay together as a group. You can't split them. So then my final answer is going to be 1 minus x over 1 plus x, and I'm just going to put this negative out front from the 2x. Okay, you could put it in the bottom, you could put it on top. If you put it on the top or the bottom, you either need to multiply the negative through or put parentheses around it. But if you just throw it out front like this, that just says I'm making the whole thing negative, because that's what's going to end up happening with it. Any questions about that? Have y'all seen these before?
Yeah.
Okay.
What's the fractions where it's like, I can't remember, but I do not understand them at all. It's like,
Probably complex with eyes in them.
maybe? It's like, I have to look it up.
It's where you like multiplying by the conjugate is probably what you're thinking.
It's like we gotta like reverse, it's like the other version of the upside down fraction thing. It's like, I don't know how to explain it, we did last year. It's like the fraction thing is like upside down. I don't know.
A fraction bar is upside down?
Yeah.
An upside down fraction bar would just look like that. Like there's one, here's another one, upside down.
Dividing bar, dividing. Like
Like this?
yeah, but then no.
But it looks
Maybe.
like this. It probably looks like this.
Maybe.
It's probably synthetic division.
Synthetic division, but it was like the weird version. The hard version.
Polynomial long division?
Probably that.
Yeah, I don't really teach that. I will show one example usually to make them appreciate synthetic, but that's about it.
Because I can't do it.
Yeah. It's super, super complicated the first time you see it, but once it, like, you see it again, it's like, oh, like, that does, like, logically make sense, because it works the exact same way as regular division. It just looks weird because there's x's in it, or whatever variable. Yeah, that's probably what it is. Most people don't like that. Let's do one more like this, and then I'll let y'all have whatever time is left to work. 84. So I've got x plus 4 over x minus 3 over x minus 2 all over x minus 2 plus 1 over x.
Okay.
Any suggestions?
Can you cross those out or no? No.
Because they're being added. If they were being multiplied, yeah, I could.
Well,
Sort of.
you have to get the both top and bottom with the x minus 2.
Okay, so I'm going to do this, and that's only because they already had x minus 2's, obviously, on both. And then what do I need to multiply the other ones by? Because think, when I multiply this one, I'm going to have x times x minus 2.
Oh.
So what am I missing over here to get a common denominator?
An x.
Yep. So then, I'm going to write it down here below just because it's going to get a little crazy. So on top, I'm going to have a fraction bar with x times x minus 2. I would say don't multiply those through, again, just because you never know if something's going to end up canceling for you in the end. And since I ended up having the same denominator top and bottom, I can be pretty sure that it is going to cancel. So I'm just going to leave it just to make life a little bit easier. So on top, I'm going to go ahead and FOIL this. So I'm going to get x squared, let's see, minus 2x plus 4x, so that's plus 2x, and then minus 8. And then over here on this side, I would have minus 3x. All over. Again, I still have x times x minus 2 on the bottom of it. And then the top of it, I'm going to have x squared. And then I'm going to have x minus 2, or plus x minus 2, sorry. So when I rewrite this, I try to write as few steps as possible when it's like little tiny things that I can. If you want to write it out in as many steps as your heart desires, go for it. But I'm going to go ahead and combine like this 2x and negative 3x when I'm writing it for keep, change, flip, because now I'm ready to do that. So this is going to be x squared minus x minus 8 over x times x minus 2 times, so flip it, x times x minus 2 over x squared plus x minus 2. So then the x and the x minus 2 cancels. And And so we're left with x squared minus x minus 8 over x squared plus x minus 2.
Is that the answer?
Yep. I probably should make sure that it doesn't factor any farther than that, but I don't think that it can. 2 and 4. 8 and 1. Yeah, I don't think it can factor any farther. If one of them could factor and then they could cancel again, obviously I would want to do that, but I don't think this one can, so I'm just going to leave it. And hopefully I'm not wrong. All right, I think I put some problems up at the very end yesterday, but I don't know if y'all got them written down, so I'll write them down again just so you have them. So this is a longer section, so there are a few more problems, but 9, 15, 19, 27, 35, 41, and then 57, 69, 71, 77, and I'm just going to note for you that there is a sum of cubes in there, and so if you rewrite it with the SOAP formula, it'll make your life easier. And then 81. And when you're doing the common denominator for 81, you may need to factor the denominator of one of them first. Okay? But the process of it will still be the same as what we did other than that. Any questions?